the difference between this question and some of the questions we went through yesterday in terms of your grid is that you've got two things being added together, but you haven't been given a Ka. So in terms of working out what sort of question you've got, if you're adding an acid and a base and you're not given a Ka, then you know then it's a strong acid and a strong base. So they're both completely dissociated, which means that you can just work out what's left over after the reaction, okay? So what I want you to do is write out the reaction. Now what you could do for this one, you've got HCl, and you've got CaOH2, okay? So you could write out the reaction as HCl plus CaOH2 makes calcium chloride plus water, and you can balance that. You could put a 2 in front of the. Let me just zoom out slightly. A 2 in front of the HCl, and I think a 2 in front of the water as well. Okay, you could do that, but the problem with that is when you've got those ratios, that makes it slightly more difficult to work out how the acid and base reacts together and which one to times by 2 or divide by 2, particularly if you have something like phosphoric acid and calcium hydroxide, where it will be like a 3:2 ratio, and that makes things more complicated. So I don't want you to do that. I'm going to represent that by putting a line through there in red. And instead, what I want you to do is think about the Ionic equation for neutralization. Okay, you should have learnt about this in year 11 or 10 probably, and that is H plus OH minus makes H2O. Now the reason why that makes things easier is because the Ionic equation for neutralization will always be 1-to-1. And what you've just then got to work out is how many OH minus ions or how many H plus ions are present, just like you've been doing already. You just got to look at the number of OH minus ions in the alkali and the number of H ions in the acid. So let's do that next. So you want to work out how much is at the start. So for H plus, you've got 25 centimeters cubed of 0.6 mole per dm cubed HCl. So we're going to do 25 times 0.6 over 1,000. And for OH minus, we've got 10 centimeters cubed of 0.2 mole per dm cubed CaOH2. Now the fact we've got 2 of them means we need to multiply our answer that we get here by 2. What we've worked out here for the H plus is actually the number of moles of HCl, but we know that's the same as the moles of H plus because there's only 1 H plus per HCl. But when we work this out for CaOH2, for the calcium hydroxide, that's going to be moles of calcium hydroxide. We want the moles of OH minus ions in solution, so we're going to multiply that by 2. So for OH minus, it will be 10 times 0.2 over 1,000, but we're going to multiply that by 2. And that's where we're kind of doing the ratio bit that we would do up here, but it makes it easier because you will find that it's easier if you've got more difficult ratios as well. So can someone just type that into their calculators for me? Thank you. So this first one is 0.015. Can you work out the second one for me? So that's going to be 0.004. So our next step is then to work out what's there at the end. So at the end, okay, the one that's in excess obviously is the one that we've got more of. Okay, I won't do that in green. You can't see it on the board, can you? Let's do it in black still. So we've got more of the acid. Okay, so we're going to do 0.015 take away 0.004, and that'll give me 0.011. And the key thing next is that we've got to then work out the concentration of H plus ions. And the main mistake that people make is that they think that this is the concentration of H plus ions, but these are the number of moles we're working out. So this is a number of moles of H plus, not the concentration. So to work out the concentration, I need to do moles divided by the volume, which equals 0.011, divided by and then I've got to use the total volume. So up here, at the top here, we've got 10 centimetres cubed of the calcium hydroxide and 25 centimetres cubed of the hydrochloric acid. So in total now, we've got 35 centimetres cubed. I need to divide that by 1,000 to turn it into decimeters cubed. And that gives me 0.314. And then finally, I've got to work out pH. So pH equals minus log of 0.314, which gives me an answer of 0.50. Now if you try the one on the right and see what answer you get. So here's the working of that answer. Just a few things to point out where you may have gone wrong. So first off, it's phosphoric acid we're using, which is H3PO4. So we need to make sure we multiply the moles of the acid we work out by the number of ions of H plus in there, so that's 3. And here again it's calcium hydroxide, so there's 2 OH minus ions, so I've got to multiply by 2. So you can see now why using an ionic equation where it's a 1-to-1 reaction is going to be easier than writing out the full equation and then trying to use the ratio to divide in times by certain amounts. Then we need to take away one from the other to work out the excess moles of H+, and then obviously you've got to work out the concentration of H+, not just put your moles of H+ into your pH calculation. So the next thing here I've done is given you a spot the mistake question. And the key mistake here, if you look through, I'll just give you a time to pause this. Okay, the key mistake here, if you look through, is the fact that you've got moles of OH minus here, and they've used that directly to work out the concentration of H+, and he should have worked out the concentration of OH minus first. So actually, what you should have done here is converted this into concentration of OH minus, which equals 0.00551 divided by the total volume, which is 25 plus 38.2. So 25 plus 38.2 over 1,000. And that gives me 0.0871. So that's what should go in here. And if I do that, this instead gives me, if I do 1 times 10 to the minus 14 divided by that, that gives me 1.15 times 10 to the minus 13. And then if I then minus log that number, that gives me a pH of 12.94. So that is the answer they should have got. Okay, now I'm just going to go through the questions that we ended the lesson with. So we've got 2 beakers, A and B, each contain 100 centimetres cubed of a certain concentration of nitric acid. It says calculate the pH of the solution formed when you've added distilled water. So remember that we're always trying to get to the concentration of H+, but the concentration of H+ after adding 50 centimetres cubed of water will be different to obviously the concentration of H+ in the initial solution. And to work out concentration of H+, I need to do moles divided by volume. So I've got to work out this initial number of moles in my initial solution. So my moles of H+ is going to equal 0.0125 times 100, so concentration times volume, so that should be 100, sorry, not 1,000, divided by 1,000, and that gives me 0.00125. Then I can work out my concentration of H+ by putting in that number of moles, 0.00125, and divide it by my new volume, which is going to be 100 plus 50 over 1,000. So that gives me my new concentration of H+ ions, which gives me 0.0083 recurring. So my pH equals the minus log of that, which gives me 2.08. If you got 2.07 because you rounded that should be okay. That should give you a range in the mark scheme. For the second question, asks you to calculate the pH of the solution formed after 50 centimeters cubed of sodium hydroxide added. So here we're adding strong acid and a strong base together. So we're going to use our Ionic equation for neutralization. Work out the moles of H+. Well, actually, we worked that out in the previous question, so that's 0.00125. And our moles of OH-, which we're going to get from here. Okay, so we've got 50 times 0.0108 divided by 1,000. So that gives me 0.00125 of H+ ions. And 0.00054 OH- ions. So the one that I've got in excess is my H+ ions. So to work out my moles of H+, I'm going to do 0.00125 take away 0.00054. So that gives me 0.00071. And then I need to work out the concentration of H+ to work out the pH. So that's going to be my moles of H+, 0.00071, divided by my total volumes. Remember, it was 100 to begin with. I've added 50, so that's going to be 150 divided by 1,000 to make sure it's in decimeters cubed. That gives me 0.00473 recurring, and put that into my minus log, and that gives me 2.32. Make sure you give your answer to 2 decimal places as it requests in the question. Okay, and this is the last question you'll have done in class. So we've got phosphoric acid being added to calcium hydroxide. So again, we've got a strong acid, so H+ plus OH- makes water. So my first port of call is to work out my moles of each of these to start with. Now we've got phosphoric acid, which is H3PO4, and we've got calcium hydroxide, which is CaOH2. Now we need to know that so we times by the right numbers. So I've got 10 centimeters cubed of 0.32 mole per dm cubed solution, divide by 1,000, and then times that by 3 because there's 3 hydrogens in phosphoric acid, and then I've got 68.2 times 0.75 over 1,000, and times that by 2 because I've got 2 OH- ions. So that gives me 0.0096 and 0.1023. So the one that's in excess this time is my OH- ions. So my moles of OH- ions is going to equal 0.1023, take away my moles of H+, which gives me 0.0927. And then to work out my concentration of OH- ions, that will be my moles of OH- ions, 0.0927, divided by the total volume. So that's going to be, there's 10 centimeters cubed of the phosphoric acid. Add that to the 68.2 centimeters cubed of the sodium hydroxide and divide by 1,000. And so that is 1.185 moles per dm cubed of OH- ions. So now I've got to work out the concentration of H+. When I've got OH- ions, I divide Kw by them to work out H+. So I've got 1 times 10 to the minus 14 divided by 1.185. And that gives me 8 times 10 to the minus 15. And so my pH equals, if I minus log that, 14.07.